меня слышите, да? Нет? Да, отлично. Ну хорошо, буду с микрофоном. Okay, so I was thinking what I should better present here. So it's a bit of a technical paper on it's a little bit of a tricky paper to present to a general audience. It's a paper about exchange rates, and it's sort of deeply within the literature. So I'm going to try to give you an introduction about sort of why what we're doing is relevant. But you should feel free to interrupt me with questions, and I can hear my voice, which is not very nice. А вы меня слышите? Да. Okay, so this is a paper with Dima Mukhin. So Dima Mukhin is my student at Princeton. He was a student at New Economic School before. So he's a very impressive student, and he's going to be on the market next year. So I have big plans for his placement. So in this paper, we are trying to build a general equilibrium model of exchange rates. And the challenge here is that exchange rate seems like a very basic model, very basic variable in almost any model that you write down. So if you write a model with 2 or more countries, you're necessarily going to have an exchange rate in it, right? So some models are very simple. They don't really have anything interesting to say about exchange rates. So if you take a basic international business cycle model, there would be just one good, and so there are no exchange rates. Exchange rate is equal to 1 all the time, and so that's kind of an uninteresting model of exchange rate, right? But even when you have an interesting model, so you still have this variable, and you can build more sophisticated models, and each model with more than one country will have exchange rate in it, right? And so the challenge is that almost any model that you write down actually has implications for the behavior of exchange rate, which are at odds with what you see in the data. So it's very hard to write down a model which captures sort of the very basic properties of exchange rate, right? And so what's it called in the literature, this challenge is sort of labeled by this notion of exchange rate disconnect, right? So exchange rate seems to be a variable that's largely disconnected from most of the macroeconomy. So exchange rate tends to move it's very volatile, moves in a very persistent way, and doesn't seem to correlate very much with other things that happen in the economy at the macro level, right? And so very broadly, this is called exchange rate disconnect, and this is kind of a basic challenge to the literature because we write down models with multiple countries. We want to think about things like international policy spillovers or the role of the dollar in equilibrium, why most of international lending happens in dollars and most of the trade in goods happens in dollars. But these models have completely crazy implications for exchange rates. They're totally at odds with what you see in the data, and that's why you write down a model, you study some properties in it, but then it gives wrong predictions about exchange rate, and so you don't know what to do with it, right? To what extent the conclusions you're going to have from this model will carry over to environments where you can get the exchange rate properties right. So what I'm going to do first is tell you a little more about the puzzles. It's kind of very brief here, but there are. So we split all puzzles about exchange rates into 5 groups, and so the idea is that basically pretty much any moment about exchange rate you take from the data, it has a puzzle named after somebody, right? So the point is that almost any property of exchange rates, they are sort of puzzle into economists, right? So the very basic one goes back to the 80s, so it's a Mizan-Rogov puzzle, and what they showed is that if you try to predict exchange rate, you cannot do better than a random walk, right? Which is not that, if you think about exchange rate as being sort of a stock market variable, right? So stock market variables tend to look like random walks so that you cannot make money of it, like trading dynamically. So the fact that it looks like a random walk is actually not that puzzling. What's puzzling is, so there is some sort of, like a martingale property for exchange rate, that you try to predict exchange rate at time t into t plus 1, and the best prediction you can give that the change is 0, actually. So that's the Martingale property, right? But, in general, it should be some function of variables available at time t, and so what Mizan-Rogov showed, they considered a bunch of specifications here that come out of theory, and they showed that, the 0 almost always beats any specification that you can put here, which is surprising because 0 is a very restricted model, right? So that was the Mizan-Rogov puzzle. But what's even more surprising, what they showed, is that you can try to predict change in exchange rate using variables from t plus 1. So it's not a forecast in the sense that you have information as a time t and you try to get what's going on at t plus 1. You actually can take information from t plus 1 right? Like you can see what happened to the interest rates next period, to money supply next period, to some other fundamentals in the economy, and still it's very hard to systematically beat a zero, right? So a zero tends to be an empirically the best thing you can do, right? It's not exactly true anymore. So like in the last 20 years, you can get some improvement, but this improvement in forecast that you can get using future variables, right? It's tiny relative to a random walk. And that's what's called disconnect, right? So exchange rate seems to be disconnected even with contemporaneous macro variables, right? And that's sort of like a profound puzzle in the macro literature. So the next puzzle seems sort of different, but in a way it's a very related puzzle. It's called PPP puzzle. That's also associated with the name of Rogov. So Rogov 96 is like a famous survey article. And so what this puzzle says is PPP is PPP puzzle. Essentially what it means is if you look at real exchange rate and nominal exchange rate, the two variables tend to move perfectly together. So the correlation between the two variables is something like 0.98 or 0.99. And so real exchange rate, that we're going to use it quite a lot. So real exchange rate is nominal exchange rate. Well, real exchange rate is the relative price of consumption bundles in the two countries. So you take the price index at home, price index abroad, and convert it to common currency. And that's the real exchange rate. So if you have purchasing power parity, it says that the price levels should be the same in the two countries, so it should equal to 1. So this would be the purchasing power parity, right? The deviations from purchasing power parity, you can call it real exchange rate, right? And so in the data, real and nominal exchange rate tend to move perfectly together, up to horizons of 3-4 years, right? And so the point is that somehow, you know, when nominal exchange rate moves, the prices don't move at all, right? That's kind of the idea, right? And so it's sort of related to this, right? In a way, it says that, you know, you could put price levels here, like inflation rates here, and they're not particularly correlated with the nominal exchange rate, right? And as a result, real exchange rate sort of, you know, is almost 1-to-1 the nominal exchange rate, right? And so this has been sort of an important puzzle because, you know, when people looked at exchange rates and they see how volatile they are, so a typical exchange rate moves by something like 10-12% a year. The stock market moves by about 16 to 20% a year. So exchange and like consumption and output move by like 1 or 2% a year. So exchange rate is something like 5-6 times more volatile than macro variables and about 2/3 as volatile as the stock market, right? And so when people see this volatility, they kind of conjecture that it cannot be productivity shocks, right? Productivity shocks are much smaller, right? Productivity shocks got to be on the order of magnitude of, you know, GDP fluctuations, right? Like 1-2% a year. In terms of standard deviation. So they conjectured it's got to be monetary shock, something coming from the nominal side of the economy. And then, you know, if it's a nominal shock, you expect both exchange rate and prices respond to it, right? So prices can respond slowly to it because prices are sticky and so on. But eventually, you know, all nominal variables should respond to monetary shocks, right? And so this is why it's puzzling that you can have this exchange rate nominal exchange rate moving around, but prices almost not responding at all to it, right? Over, you know, horizons of 3 to 5 years, right? And so that's the PPP puzzle. The next puzzle is, so the way we think about this too, these are puzzles about the, you know, zero order behavior of exchange rate, about sort of well, you'll see why we call it a zero order behavior. And this is about the first order behavior, right? So this say that there are no correlations essentially between macro variables and exchange rates. This three will say that there is actually a mild correlation. It's a very weak correlation, but there is a particular sign of this mild correlations that are also puzzling, right? So this last two are the more famous ones. So this one is called Becker-Smith puzzle. And the Becker-Smith puzzle essentially says, so the international risk sharing condition looks like, so in a model with complete international risk sharing, well, up to a constant, some constant kappa, but we can, you know, we can normalize it to 1. This actually doesn't matter. And so what this condition says is that consumption in a country, and my definition would be when exchange rates move up, it's a devaluation. The reason is like, think of it as like how many euros you need to give for $1. So when it goes up, you need to give more euros for $1, so euro depreciates. And euro will be my home country. Germany will be my home country in the model. And so the idea here is that the consumption, if you have perfect risk sharing, consumption should be high when exchange rate is devalued. And what's the rationale here? So basically, when exchange rate is devalued, it means that prices are low. When prices are low, you expect consumption to be high. And it turns out to be, it happens both in models with complete markets and models with incomplete markets for other reasons. But this is a condition from models with complete markets. And the way to think about it, right? The models with complete markets, they replicate the planner's allocation. And the planner wants to give consumption to the country which has a low price level, because it's like when the planner has 1 unit of resources in his hands, he's thinking to which country to give consumption on the margin. And he would prefer to give more consumption where it's cheaper to deliver consumption. So prices reflect, how cheap it is to deliver consumption in the country. I mean, it doesn't sound intuitively if you, try to explain it to your parents, but from the point of view of the models that we use, this is kind of well within the logic of the models. And that's a very, sort of robust relationship in the model. So with complete markets, the correlation between the two is +1, right? In the data, it's about -0.2. And that's the Beck-Smith puzzle, right? It says that not just the two variables are not particularly correlated. Up to 0 order, the correlation is 0. But if you want to get like a first order approximation, the correlation is a weak negative number. And this is sort of puzzling because most models, even when you relax complete markets, most models that you write down is going to give you a very large positive number, close to 1, right? And that's been a big puzzle in the literature. And then there is a forward premium puzzle. It's a puzzle about interest rates. And so when I use small letters, these are logs of the big letters, right? So this small e is the log of the big E. So I'm going to mostly work with logs. So this is a return differential when you buy a home bond versus a foreign bond. So you can make this interest rate in home bond, this interest rate in foreign bonds, but they're in different currencies. So you have to adjust for expected appreciation or depreciation of the domestic currency. So if the domestic currency pays a high interest rate, it better be that you expect it to depreciate, right? And so this 0 is like a no arbitrage condition between the two bonds. I don't know if you know Fama regressions, but Fama regression, so this is one of the things for which Fama got the Nobel Prize. So he regressed the change in exchange rates on interest rate differential. And this model suggests that it's called UIP, uncovered interest rate parity. So the parity suggests when you regress expected exchange rate depreciation on interest rate differentials, you should get a coefficient of 1. That was the Fama regression. Instead, you find a coefficient of minus some poorly estimated, with big standard errors, but a negative number typically, like something like -0.5 maybe, right? And so this is the UIP puzzle or forward premium puzzle. Why is it a forward premium? Because you can write forward contracts on exchange rates, right? And so that's why it's called a forward premium. So now you see there is kind of an interesting pattern here that, you could ask, well, you're telling us about correlations here, but you just told us that there is no correlation. So in a way, it's consistent. So what it says is that the R squared, if you try to predict stuff here, R squared is very small. And within sample, you're always bound to get positive R squared. But when you try to predict out of sample, you can start getting negative R squared. So this is what it's saying, that within sample, even if you get positive R squared within samples, right, it doesn't help you forecast outside samples, right? That's the disconnect here. And so when you look at the correlations here, these are very weak correlations. So the R squared in the Fama regression is about 0.02. So you get a negative coefficient, but the R squared is kind of a very small number. So it's not inconsistent with this, right? Okay, and so the last puzzle this is maybe less prominent puzzle in a way, but it's a very interesting one. So there is a notion of terms of trade. Terms of trade is import prices divided by export prices for the country. And so in standard models, when you write it down, terms of trade should be more volatile than real exchange rate. And the idea is that real exchange rate is about the consumption bundle. So consumption bundle includes both domestically produced and foreign produced goods, right? And so the consumers, they have the ability to kind of diversify between home and foreign goods. When foreign goods become more expensive through your consumption bundle, you can buy more of the domestic goods. So terms of trade reflects that the foreign goods are becoming more expensive, and real exchange rate is kind of a smoothed out version of that. So in standard models, real exchange rate is supposed to be less volatile in terms of trade. In the data, it's about 3 times more volatile in the terms of trade, right? And so it's again the statement that, and so what's interesting here is the terms of trade is actually a variable at which trade happens, right? So terms of trade is literally the price of exchange of home goods for foreign goods. Like literally trade happens at that price. Real exchange rate is not a price. It's artificial variable, right? It's some statement about relative price of consumption bundles in the two countries, and nobody can trade the consumption bundle. It's not a tradable good. So as a result, terms of trade is a real variable at which some trades happen. Real exchange rate is an artificial variable, and so kind of you get this pattern that you can get volatile and unconnected exchange rates, from actual macro variables, right? And so then if you look at the correlation between terms of trade and real exchange rate, it's a pretty weak but positive correlation, right? So none of what I'm saying here is sort of new, right? These are standard puzzles out there in the literature, so that's why I'm saying it's a little difficult paper to present, because it's sort of like decades of research on all of these puzzles. So we want to take all these puzzles together and kind of write down a model, which we want to see whether it's possible to write down a model that would be jointly consistent with all these facts, right? So typically the way the literature addressed things, it would take one puzzle at a time, and try to resolve one puzzle at a time, right? And oftentimes it happened that, and you see these puzzles are kind of different in a way. So this is about asset markets, it's about interest rates. This is about risk share, and then, in very RBC style models, people typically try to do it. This is about kind of nominal price stickiness, people try to do it, right? So they were completely disconnected by the styles of models that people use to get at this, right? So these were financial models, these were real models, these were nominal models. And this was like a crazy thing altogether, right? And so what we try to do is we say, well, this is actually, this gives you a joint discipline on behavior of exchange rate. So you better take all these puzzles together and try to have a common framework for thinking about that. And so the question is it possible at all, and what this sort of requires? So now, this is sort of a bit of a motivation to, one could say, well, maybe these things just don't matter at all. Maybe, exchange rate is some, crazy volatile variable, who cares about that, right? So this actually kind of, this was really striking to me. So I was in Australia in somewhere around 2011, I think, and they told me that Australia is the richest country in the world. And I'm like, no way, 10 years ago, Australia was not that rich, right? It cannot. And when you think about growth, right, you think that, countries grow maybe at 5% a year, maybe at 3%. Rich countries grow maybe 3 to 5% a year if they do remarkably well. And so, nobody can think of country doubling in GDP in less than 10 years, right? It's completely crazy sort of for a fairly rich country, right? And so what you see here, so what I plot here, it's a nominal GDP per capita for 3 countries, United States, Australia, and Switzerland. And so it's in dollars. So it's nominal GDP per capita in dollars. That's why the US line is kind of a smooth, typical trend that you see, right? And so because it's nominal, you don't want to compare over time, right? Because over time, there could be inflation and stuff, so it doesn't tell you about the change in the quality of life over time. But what you can do, you can take a slice and compare countries, right? So the comparison across countries is still meaningful. So the way I think about it, it's like you take a typical Australian and typical American and put the two of them in a duty-free shop in some airport, right? And this would reflect their purchasing power parity, right? That's the nominal GDP per capita in dollars. So if they're in the same store, that perfectly reflects their purchasing power. But obviously the typical store in Australia and the typical store in the United States doesn't have to offer the same prices at all, right? That's the violations to the purchasing power parity, right? And so what you see happens is that Australians were about 2 times poorer than Americans in 2000. So only about 10 years ago they were twice poorer than Americans, and then over 10 years. It was totally crazy, right? They became 2/3 richer than Americans, right? So this is spectacular. This, you never see this in real terms, right? So in real terms, nobody becomes so fast, so rich, right? If you look at China, nothing nearly close happened in China with a 10% growth, Yeah. So the point is that, what happened here? Well, there was a massive appreciation of the Australian dollar. So Australian dollar appreciated. And Australia suddenly it was way poorer than US and became way richer than US. But it actually doesn't reflect that typical Australian started living so much better. Why? Because, price levels increased in Australia at the same time, right? Because this is measured in dollars, right? So incomes increased in dollars, but price levels also increased in dollars, right? So from the point of view of typical Australians, not all that much has changed. Well, it was a boom period because of commodity prices, but it's not like they became, how many times? It's not like they became 4 times richer, right? Nowhere near that. And so the point here is that this crazy exchange rate movements, they result in this phenomenal movements in national aggregate statistics but they're kind of inconsequential to a large extent, right? And so this is the type of model we're thinking about. How can exchange rate moves by so much and yet not translate into anything, very important for the countries, right? And so the same thing happened with Switzerland, right? So Switzerland was as rich as the United States in 2000, and now it's 2 times richer than US, right? So this was the demand for Australian commodities. This was demand for Swiss assets. So something like this is going to be happening in our model as well, right? And so here's another example. So this is a British pound. I mean, you can probably guess what this was. So this was the Brexit, right? So on the Brexit vote, it devalued by more than 10%. And like you can ask what happened when Brexit happened. Well, people sort of became psychologically depressed in London. But, in terms of economic activity, nothing really happened, from yesterday to the next day, right? So it's sort of trade of Britain didn't change, incomes of people in Britain didn't change, price level didn't change, but you had this discontinuous movement in exchange rate. So this is exactly the type of disconnect we have in mind, that some macro variable like exchange rate, both nominal and real, can discontinuously jump by a large amount in one day, and it's actually really kind of inconsequential for the rest of the economy, right? So this is why it's a big puzzle, right? How can that happen, right? If it's an exchange rate, it's a macro variable, it probably should be connected to fundamentals and stuff, but you can have jumps and sort of nothing else happens. And we want to write down a model where this is there is something that happens to fundamentals. There is a jump because of change in fundamentals. But this is not consequential for the rest of the macroeconomy, basically. Or not very consequential, right? So that's the idea. So does it make sense? Okay, so I mean, essentially, as I mentioned, what we try to do is have this unifying theory of exchange rate that's kind of jointly consistent with sort of this 5 broad properties that we identified. And in order to do that, I need to kind of tell you 2 things about the model. So I need to tell you what is the shock process, what's the key shock that drives the exchange rate. And once the shock hits the economy, I need to tell you how it gets transmitted through the economy. So I need to explain how the transmission mechanism looks like, right? So these are basically the 2 ingredients. And so it turns out that the transmission is going to be very, very straightforward. So it's something about which we know quite a lot from microdata, right? So part of my work was about understanding the transmission mechanism, more empirical work. And we actually have quite a lot of information about how the transmission of exchange rate works. So once exchange rate moves, we know fairly well how they affect prices, how then they affect quantities, how they affect interest rates. And so it turns out that we're going to only need 4 ingredients here, which are very, very simple ingredients. So the main ingredient, in a way, would be home bias, right? That countries are fairly closed. So a typical, we're going to focus on United States, European zone as a whole, Euro area, as a whole, the Euro currency area, and Japan. So these are 3 big economies which are fairly closed economies. So in US, if you look at what's the typical expenditure of foreign produced value added in the American consumer's basket, it's going to be about 7-8%. So only 7 or 8% of typical US household expenditure is going to be on foreign value added. The rest, like 92% would be on the US value added, right? And so it's not surprising, given like if you think housing is about 25% of the consumption basket. That's a domestic ingredient. Then you have all sorts of services, which is going to be another 50% of the consumption basket. So, and then you have manufacturing, which itself is only 20%, and still most manufacturing is domestic value added, right? So that's the idea. So that's going to be a key ingredient, is that countries are fairly close to each other, right? So this leaves a question of what you do with countries like Switzerland or Sweden or UK. So what we're going to do today would be too basic to think about those small countries, but we kind of sort of know how to model the smaller countries as well. That would require a more involved model. So this model would be remarkably simple, as you will see, right? And so then we can think about big countries with this model. So home bias will be the first ingredient. Then we need strategic complementarities and price setting, which means that when firms set prices, they care about their marginal cost, but also they care about prices of their competitors, right? And so the question is how much weight they put on what their competitors are doing. And the idea is we need fairly strong strategic complementarity. So they care quite a lot about what their competitors are doing. They don't want to change their price by too much when their competitors are not changing the price, right? And so the idea here is that the firms will face different set of competitors at home and abroad. right? So the domestic competitors are not the same as foreign competitors. So as a result, you would want to charge different prices on the two markets. And that's sort of the idea of strategic complementarities. And this mechanism is called price into market. So the reason you choose different prices when you sell the same good in different markets is that you face different set of competitors in different markets, right? And so we exactly know how strong is home bias in the data. We exactly know how strong are strategic complementarities in the data, right? So what this will do is when exchange rate moves, the prices won't move very much, right? The prices won't move, the export and import prices won't move very much. This will result in fairly stable terms of trade, right? Why they don't move very much? Because you don't want to depart, like when Volkswagen sells the car in the United States, it doesn't want to depart from the prices of Toyotas and Hondas too much in the United States, right? And so they keep even when euro appreciates or depreciates, they tend not to change the price of Volkswagen in dollars in the US market. And so that's what keeps the prices stable. But still, prices move somewhat. And so what you want, you don't want if prices move, you don't want consumer, like imagine euro depreciates, euro depreciates by 10%, Volkswagen prices, go down by 2%. Still, consumers might, want to substitute away from Hondas to Volkswagens. But what you want here is that substitutability is fairly weak. So you don't have a very large elasticity of substitution even when prices. And so what this would do, prices will move somewhat in response to exchange rate. And quantities will move somewhat, but this will limit the movement in prices, and this will limit the movements in quantities. So you want weak substitutability between goods, right? And so we're going to, again, take the number from the data. So you see, these are very kind of basic mechanisms. And the last mechanism that's essential is that the countries have a monetary policy defined by a Taylor rule, so that the countries stabilize domestic inflation, right? So they choose interest rates to keep domestic inflation stable. And it turns out, and we're going to use a standard Taylor rule that's estimated in the data, right? And so all of this we kind of know very well. What's amazing is that there is no need for nominal stickiness. There is no need for sticky prices at all. So it's going to be, the basic model will be a flexible price model, and then we're going to add sticky prices on top of it and other stuff. But the basic model, it would be like, you actually can do it as a problem set, this model, because it's completely analytically tractable. And then, so this we know fairly well. In terms of the shock, I'm almost done, right? So in terms of the shock, we know very little. So like if you try to figure out what is the nature of the shock that hits the exchange rate, the answer is that, well, even after things happen, it's very hard. Like you look in some, on some day exchange rate moves by 1%, you try to figure out what was the shock that moved the exchange rate. And it's actually very hard even like exposed to account for what was exactly moving the exchange rate. To a large extent, it's some unobservable shocks to econometricians, right? And so as a result, we're going to take an agnostic position here. We're going to say we sort of don't know what are the shocks. So we're going to allow for all possible shocks, and then we'll be able to prove kind of theorems saying which shocks can generate properties that we want and which shocks cannot generate properties that we want, right? So it would be a theoretic. So we're going to get some theoretical guidance here as opposed to like empirical guidance for this. So I have like another 20 minutes? Yeah. Okay. So this was a very lengthy introduction. I mean, I'm not going to be able to show you much of the model, but the model is very standard. So I mean, this is like a basic sort of macro model. So you have every macro paper will have this structure basically. And so you have consumers that maximize intertemporal utility over consumption and this utility of labor. So what we're going to do, as I mentioned, we're going to allow for all possible shocks. So this red things, if you can see things in red, these are the possible shocks in the model. So for example, this shock is called a labor wedge. It's something that makes people want to supply more or less labor over time, right? And so it's a stand-in for unmodeled pieces of the model. So for example, you can think of a sticky wage model where, because wages are sticky, people would like to work more, but they can't. It would be equivalent to a labor wedge, which sort of makes people want to work less. It would be equivalent to kappa going up. So it's like a reduced way to capture lots of unmodeled things, right? And then eventually we're going to switch this off and put sticky wages into the model. But it's a very simple way of capturing a lot of the unmodeled ingredients. So this shock, it's like an intertemporal preference shock. If people want to delay consumption from today into tomorrow, they can have a negative shock here, right? So this is like an intertemporal preference shock. So, and this will be the budget constraint, and it's like this is a German household. They can buy either domestic bond or the foreign bond. The domestic bond pays in euros, the foreign bonds pays in dollars, and you convert it using exchange rate backs into euros. And you have expenditure and consumption, wage bill, profits, taxes. So it's kind of completely standard. And so the optimality conditions out of this model. So this is the labor supply condition, and so labor wedge and the labor supply. And this is demand for bonds. So theta is a stochastic discount factor. It's how you discount the future returns. And this is a home risk-free bond. So this is the pricing equation of a home bond, right? And this is the foreign bond. I'm going to put a shock here. This is going to be my financial shock. So I put it here in the budget constraint. It's like a reduced form thing right now. So we can think about micro foundations for this. So, I'm not sure I'm going to have time today, but there are about 5 different stories, what can be a source of that shock, right? So maybe I'm going to mention a couple of them. And so, but this is the return on the international bond in dollars, on the dollar bond. But you have to adjust the stochastic discount factor with the nominal exchange rate, right? Because this bond pays in dollars. And this tells you the value of €1 tomorrow. So you need to use the exchange rate tomorrow to convert, the dollars that you're going to get into euros. Then you can calculate the value of €1 tomorrow in a particular state of the world. That's what stochastic discount factor does, right? And so you see the intertemporal preference shocks, they show up in the stochastic discount factor. They tell you how much you want to sort of substitute consumption intertemporally. While this shock only shows up on the dollar bond, right? So the way to think about it, like Germans wake up and they realize they have a demand for the dollar bond. That dollar bond gives them some unmodeled liquidity or some unmodeled safety, and so suddenly they need that more beyond what it reflected in the interest rate, right? So what it means is that they will be willing to hold dollar bonds even when the interest rate is low. So even when R star is low, a positive shock here will, make them want to keep the dollar bonds in their hands, right? So this is kind of the and then the rest of the structure. So you have, when you have expenditure, you split expenditure on home goods, on foreign goods. We're going to model a specific shock to the demand for foreign goods. So Americans can wake up and suddenly they feel like they prefer German goods over American goods. And that would be this shock, right? And so the home bias would be the expenditure share on the foreign goods. And that's going to be parameter gamma. That's going to play a big role. And theta would be substitutability. So H is some function which tells you how sensitive you are in your consumption to changes in relative prices. So the elasticity of this function is like elasticity of substitutability between different goods when the prices change, right? And so this theta is another important object in our model, right? And so, we're going to have a few more slides of this. Production function is standard, uses labor and intermediates. There is productivity shock. Firms make profits, demand labor and intermediate goods. This is kind of all standard. So the only non-standard part is, this is the price setting. And so this is what I call strategic complementarities, right? So there is firms, when they set prices, they put some weight on marginal cost and some weight on prices of their competitors. And the set of competitors is different in the two markets, right? So this is how the German firms price in Germany, and German price the same goods in US. And the difference between them is that they face different price levels in the two countries, right? And so these are also the markup shocks. It's some unmodeled reasons for why markups can be different from what the firm wants. So for example, sticky prices forces you to keep prices constant. Even if you want to change it, it will look like one of these markup shocks, right? And again, so we're going to switch those shocks off and bring sticky prices in eventually. But this is like a simple way of getting at it. All right, so the rest is just closing the model. So we say that, there are market clearing conditions. So whatever is produced in Germany and sold in US goes to US consumption, US intermediate inputs, and US government spending, right? So it's kind of just the market clearing. This is market clearing in the bonds market. So we assume that German bonds are only held by Germans, and the US bonds are held internationally. So this is the market clearing. This, like a lot of things, are to solve the model analytically, and they're not that essential. And, accumulation of net foreign assets, when you run trade surplus, net export is positive, you accumulate net foreign assets. Right? So this is sort of the basic structure of the model. Oh, yeah, and S is what I call the terms of trade. It's relative price of imports divided by price of exports, right? And this is the price at which you actually exchange imports for exports, right, as I mentioned. Okay, so this is the structure of the economy. So let me show you a couple of results. So here's the basic idea of like how we're going to, so you see we wrote down a model. We actually had 15 shocks in the model. So there are 15 possible things that could move around and lead to fluctuations in the exchange rate. So we now can prove a couple of theorems which tell us which shocks are the likely one to give us the right properties of the exchange rate, right? So here's the idea here. So if you think about economies that don't trade between each other, So there is just no trade in goods between the countries. Exchange rate becomes an irrelevant variable, right? Exchange rate can be anything, right? If Germany and US are not trading at all, you can quote any exchange rate between euros and dollars, and it's completely irrelevant, right? It's not going to change anything because there is no trade, so it's just a completely an artificial number. So the idea here is, let's try to think about when you're not quite an autarky, but when you're near autarky, when you almost trade nothing. So the Germany and US trade, but very little, right? And the question is there some continuity property that, when you're exactly in autarky, you can get a complete disconnect of exchange rate. Exchange rate doesn't have to be related to any macro variables at all. But can you get a continuity property that, like epsilon away from autarky, you get similar property that exchange rate can jump like crazy without affecting the macro variables, right? And so the way we formalize this is in this, formal condition. So Z will be all my macro variables. So Z would be like prices, wages, consumption, labor, output, and interest rate. So 6 variables. And so what I want is to find the shock. So epsilon would be like a combination of shocks. I want to find the shock that will move my exchange rate, but will not move in the limit the macro variables, right? So that's this idea that you can get a volatile exchange rate moving around, but in the limit as economy, so this gamma was the home bias, right? So as home bias becomes complete, as countries don't want to consume foreign goods at all, so this is where there is no trade between countries in this limit. I want macro variables to not respond to the shocks, right? So this is this idea of exchange rate disconnect and the autarky limit, like for which shocks it happens. And the point is here that this is non-trivial in the sense that we take situations when gamma are positive but going to 0. So when gamma is exactly 0, this is like you can get sort of all sorts of things moving exchange rate. But here we want to be actually away from 0 so that the equilibrium exchange rate is pinned down by fundamentals still, right? So it's not a sunspot shock. It's actually a fundamental shock that drives the exchange rate, right? And so what we can prove is that basically there are only 3 shocks in the model. Out of 15 shocks, there are only 3 that can have this property. And so the idea of the shocks is these are all the shocks that happen sort of at the border. So the shock we're going to focus the most on would be the financial shock. It's that psi shock that showed up on the demand for dollar bonds, right? So Germans wake up and suddenly they want the American bond, the dollar-priced bond, right? And so this is one of the shocks that can give you these properties. The other 2 shocks, remember there was a shock when the Americans wake up and they want German goods. So that shock will have that property. And the third shock is Germans out of the blue, completely like not driven by anything, increase their prices that they charge to Americans without changing the prices that they charge in the domestic market, right? So it's a what I call a low fund price deviation shock, or like a markup shock for the foreign market. So all of these 3 shocks can have these properties, and the intuition is that, as the economy becomes close to international trade, these shocks become irrelevant, right? What happens in international trade in either goods or assets becomes unimportant for the allocation in the economy as the economy becomes more and more close to international trade. So that's why these shocks work. So the proposition that we can prove here is that if you're trying to build a model without these shocks, there is no way you can get this property, right? So it's sort of like a negative result. So for any model that does not have any of these 3 shocks, there is no way you're going to get this property, right? And so this excludes the 2 most common shocks in the model. This excludes the productivity shocks, which are typical in RBC models, and it excludes nominal monetary shocks that are typical in New Keynesian models, right? So as a result, it just says that if you try to start with a productivity shock model or with a monetary shock model, you're unlikely to get the disconnect property. It's kind of like a hopeless exercise, right? So, and most of the literature sort of use those 2 types of shocks to try to get this properties of exchange rate, and it's just not a very good idea to start there, right? So yes, so in a way, you see, this reminds you a bit like the Mizan-Rogoff, right? That you can have a situation when exchange rate moves in a disconnected way from macro variables. So you can get something like this. So this is like a 0-order property, right? So you can get Mizan-Rogoff out of this. It turns out, remember, one of these variables can be the price level, and I put price level in there, so you can get something like this. You can get exchange rate moving without prices moving, so you're going to get real exchange rate moving together, right? And so you can get the second puzzle. So that's why I'm saying it's a 0-order property. It's a property about, the level limit. So it's a 0-order property. So these were the first 2 puzzles. So you get, for any of the 3 shocks, you can get the first 2 puzzles, the Mizan-Rogoff and the PPP puzzle. in the autarky limit. So the next proposition would be about first order properties. Is that we want, so this will be convergent to 0, but now we're going to care from which side of 0 it will be convergent, right? So we want to care about, the fact that consumption is negatively correlated with exchange rate. So when exchange rate, goes up, we want consumption to converge to 0 from below, right? So this would be like a first order property. And then same thing for interest rates. And so then we can prove that out of these remaining shocks, only the financial shock will have that property, right? So if you want to get not only the first two puzzles, but the next three, which are about terms of trade, consumption, the Backus-Smith, and UIP, which is the interest rates. If you want to get all of these three, it can be only the financial shock that gives it to you, right? So this tells us that if you want to write down a model with one shock, it better be the financial shock, right? So that's sort of the idea. What we're saying here is not that productivity shocks, for example, are not important in the data, right? We're making different statement here. The statement we're making is if you want to write down a model which has the right exchange rate properties, it better have the financial shock. It can have the productivity shock on top of it, but the productivity shock cannot be very important for exchange rate dynamics because then it's going to screw up the properties of exchange rate. So this is really the first part of the paper where we kind of establish which shock it should be. Then we have two more parts of the paper. I'm going to give you a little bit of the flavor. So what we do in the next part, we depart from the autarky limit. So we're no longer in the case when economists trade little. We're going to have countries trade exactly like they trade in the data. So they do trade quite a lot, but it's still not that much. But it's quite far away from the autarky limit. And so this financial shock, this psi, it actually shows up. So remember we wrote this UIP condition. So the financial shock is essentially a shock to that condition. It tells you that, remember how we thought about this as like, Germans wake up and they want the dollar bond. When the shock is positive, they're willing to take, they want a high interest rate on German bond relative to dollar bond. They're willing to take a low interest rate on the dollar bond if they, if there is a reason they want it, right? And there are about, so we have the slide here, which talks, so in the literature, there are about 5 different types of models that can rationalize this equation. So there is a huge, macrofinance literature that builds microfounded models of the shock, right? And so that's a whole, I don't know, if I wanted to cover it, it's about like 5 lectures. But these are all interesting models. Some of them are easy to put in general equilibrium. Some are hard to put in general equilibrium. In the end of the, you see, so some of the models can be models of limits to arbitrage in the financial markets. So some of the models can be about heterogeneous beliefs and expectational errors in the financial market. Some can be about financial frictions, and some can be about just risk premia. That this shock can be a reflection that you require risk premium on a German bond. And so the first story is you wake up and for some reason you want a German or American bond, right? So all this probably in the data, all of the stories sort of to some extent account for some of the features of the data. But what was important for us is that we actually don't care what's the structure of the story, right? So we only need that shock, and from the point of view of the macro moments we focus on, it's actually kind of the same thing for us. So we don't want to take a stand here. If you start bringing in more moments, like about the financial markets, then you kind of sort of able to distinguish between this models. So this is sort of the next step, which we're not doing in this paper, is try to actually use more data to try to figure out what's the right story. We're going to just be agnostic about what it is, right? And so given the shock, what we will figure, what we'll see from our analysis, we need the shock to be, it can be a small shock, but a persistent one, right? So I'm going to show you 2 things, and I think I'm going to stop. So I will take another, 4 minutes maybe. So then the point is that, we have parameters in the model. So the key parameters were alpha for strategic complementarities, theta for elasticity of substitution, and gamma for openness of the economy. And we basically take these numbers from the data. Right, so we take the shock, make it small and persistent, take the numbers for stuff that we can measure in the data just directly from the empirical studies, and we just see what happens in the model. So now we can solve the model. So here's here's how we solve the model, and you can sort of look at the paper how we do it. It's a completely analytical actually exercise at this point. So you have to start for the relationship between nominal and real exchange rate. Then you can figure out the relationship between exchange rate and prices, terms of trade. Then you figure out the relationship between exchange rate and quantities. and then exchange rate and interest rates. And these are all static equations of the model. And then you go from here and you figure out the dynamics of exchange rate and equilibrium. So there will be only 2 dynamic equations in the model. That's why you can solve it by hand. Everything else comes from the static equilibrium. Like basically, you know, a lot of the things this will come from price setting. You know, this will come from just market clearing and the goods and labor market. So these are static conditions, right? And this will come also from, you know, the relationship between interest rates and consumption. So all of this is static. That's why we can solve out most of the things in the model and get to the only 2 equations that determine the dynamics of the exchange rate. And here's these 2 equations. They're very simple, actually. So the one equation we already discussed. So, you know, Germans wake up, suddenly want a dollar bond. And so what must happen, this must tell you something about future appreciation or depreciation of the euro, right? And so here's the idea. Basically what will happen in this model when you solve through it is that when Germans want the dollar bond, first what will happen is that the German interest rate will go up to, I mean, it's a question of equilibrium in the asset market of the economy, right? So Germans wake up, they want dollar bonds, but it's not like there are more dollar bonds available. So the market needs to clear. The way markets clear is that the interest rates move. So dollar interest rate goes down, euro interest rates goes up. But also what will happen is there will be an expected appreciation of the euro, right? So you're more willing to hold a euro bond if it promises you an expected appreciation in the future, right? Like euro will be able to buy more. And so this is one thing that will happen here when Germans want the dollar bonds, there would be an expected euro appreciation in the future. But it doesn't, it only tells you about which way exchange rate will move starting tomorrow. It doesn't tell you how it jumps today, right? So the jump today is not pinned down. So to pin down the jump today, you need to go to the budget constraint of the economy, right? And the budget constraint says if you run net exports today, trade surplus, you will accumulate your foreign assets. And B is the foreign assets. And net exports is a function of the exchange rate, right? The weaker is the exchange rate. When the exchange rate moves up, it's, you know, becomes a weaker exchange rate, you export more. And this comes from static equilibrium conditions of the model as well, right? So these are parameters, this lambda 2 and lambda 1 are the parameters of the model that you have solved for using static equilibrium conditions, right? And so now, so this is kind of, when you have these 2 equations, this is a system of dynamic rational expectation difference equations, right? So there are simple methods of solving it, right? So basically what you do, you put these 2 equations together and you know, sort of apply it's called a Blanchard-Kahn method, how do you solve these equations. It's like solving a system of, you know, differential equations, kind of the same thing. And so what you can do, you can solve for equilibrium process for exchange rate. It kind of looks a little crazy. This process is called ARIMA 111, but actually has nice properties. So I will show you 3 more minutes. I will show, so this is the impulse response of a change in the exchange rate. It's an impulse response of delta E. So you know when an impulse response is a blimp and then 0, that's a random, it's a IID, it's a white noise, right? Impulse response. So white noise and changes is the same as random walk and levels, right? So what this gives you is that, you know, in this model, you see there is this little yellow area here. These are expected appreciations into the future. The shock is persistent, so this will be happening for a long time. And people are pretty patient in this economy, just like they're patient in the macro models. So you actually don't discount this too much. And so what it tells you is that in order to keep budget balance in this economy, you have expected appreciations in the future. You need to have a big depreciation and impact. So when Germans wake up and want a dollar bond, what will happen in this economy is euro will appreciate a lot, and then gradually basically it will depreciate a lot, and then it will be gradually appreciating. So this red line is for exchange rate and levels. Right? So the red line is like an integral of the yellow area, basically, right? And so this looks like a random walk, almost like a random walk impulse response. So in fact, this is sort of something when you try to test whether you can reject a random walk or not in the finite sample. So the point is what fraction of the variance in exchange rate is unpredictable variance, right? So for random walk, all of the variance is unpredictable, right? So it's going to be 1. So what we get is like in finite samples, you know, this is the confidence interval. You cannot reject that it's sort of 1, right? So you get a process that looks a lot like a random walk, right? So from this model with the financial shocks, right? So this was one thing I was going to show you. So there is another thing about the real exchange rate. This is a little, I'm going to skip this. I mean, I think this is, it's an interesting part about exchange rate. I'm going to tell you 2 words about it. So the typical models, they went with a monetary shock, which we already realized was not a very useful one. but the typical literature would go with a monetary shock, and then when they look at this equation, they say, well, you really need sticky prices to get E and Q to move together, right? So we're going to say, no, monetary shock is actually not the relevant shock. Take the financial shock and make the home bias very large, right? So the home bias is large. So when exchange rate moves for financial reasons, it has very small effect on prices because the component of foreign goods and the price index is small. It's proportional to home bias parameter, right? And so as a result, when exchange rate moves, the price level doesn't have to move. And so real exchange rate doesn't have to move by much. And this is how you get the PPP puzzle without having to rely on price stickiness and stuff, right? So this is sort of, we think of a conceptually new mechanism. And I will show you one last mechanism, which we think is sort of probably the most interesting one in this paper. So it's also a conceptually new mechanism for trying to understand. So remember, this is the relationship between consumption and real exchange rate. So in the data, in typical models, you get something like this when you have complete markets. So in this model, we have incomplete markets. But so the idea is that that's like a risk-sharing condition, the Becker-Smith, which comes from financial markets. What we say here is that you have to dismiss the financial markets from being so important in determining consumption allocation. We don't believe that aggregate consumption in the countries is determined by the financial market so much. It's determined by real fundamental stuff like productivity in the country and stuff like that. And so we're going to go to the goods and labor market to figure out what happens to consumption. So we're just going to use a labor market clearing and goods market clearing. And here's the idea. If exchange rate moves, it results in an expenditure switching effect. So when euro becomes cheap, the whole world switches consumption towards the German goods, right? That's the expenditure switching effect. And so, but basically it's impossible that nothing changes and everybody just consumes more of the German goods. There is not enough supply of the German goods. And because there is home bias in this country, what should happen is that everybody will consume more of the German goods. Germans will produce more of the German goods and consume less of them. That's the only way you can clear the markets. And that's the expenditure switching in general equilibrium. So the idea is that when you have a movement in the real exchange rate, there would be, you quite naturally will get a negative sign here. That's what you see in the data, like a weak negative correlation between the two. And the idea is it's an expenditure switching effect. And so the question is why the other models couldn't get. So this is a completely general effect that's out there. It's like we're going to be true in every model that you write down. And then we're like, why people didn't figure out that there was this expenditure switching effect out there? Well, partly they didn't figure it out because models were not analytical and they couldn't write it in as clear way as this. But there was a bigger issue is that typically people had models with, for example, productivity shocks. And so productivity shocks will show up like this, right? So when productivity is high, the consumption tends to be high in the country, right? And so the interesting thing here is that these productivity effects are the direct effects. They're essentially one-to-one effects, while the expenditure switching effects are proportional to the size of the country, to the openness of the country. So these are sort of weak effects when countries are pretty closed, right? So they are proportional to a gamma, which is a small number. So in all models that people sort of wrote down, these effects would just dominate the expenditure switching effects. And that's why people were getting the positive correlations, right? And so what we did in this model, we completely dismissed these types of shocks. And we got the shocks that only, we have a shock, the financial shock, that has no direct effect on goods market. The financial shock just doesn't show up directly in the goods market. It shows up only indirectly through the real exchange rate and through expenditure switching. So as a result, expenditure switching is actually the only relationship between real exchange rate and consumption, right? And so these productivity shocks are not present. But if you wanted to write down a model with productivity shocks, what it says is you kind of have to make this thing very small relative to the movement in the real exchange rate, right? And that's been kind of a challenge for the literature. All right, so this is sort of the mechanism on which we focus. And I'm going to have to stop. So this will be probably my last table that I will show you. So obviously, we sort of don't believe that financial shock is the only shock out there. But what our models essentially suggest is if you want to get the properties of exchange rates right, it better be that most of the movements in exchange rate originate in the financial markets, right? And so what we can do, we can make the model really big and complex and put like sticky prices, sticky wages, realistic Taylor rules, kind of all the basic things that people put into DSG models, and we can put a variety of shocks together, like simultaneously have multiple shocks, and we can ask, if you look at the movements in exchange rate, what fraction of that movements must come from different shocks, right? And so what the model says is, about 70-20 is the split between financial shock and the, this is the shock when Americans want German goods, right? So it's like the demand shocks for foreign goods, right? Basically, so this is the demand shock for foreign assets. This is demand shock for foreign goods. Those shocks have to be the key drivers of the exchange rate, basically, and then the remaining thing can come either from monetary or from productivity shocks. But basically, monetary or productivity shocks cannot account for more than 10% of exchange rate movements. Otherwise, you're going to start screwing up the properties of exchange rates, basically. And so, but at the same time, these shocks can be the main shock driving consumption in the data. So consumption and production is probably mostly driven by these things, while exchange rates are mostly driven by these things. And so this is how you get the disconnect. So let me stop here with the model. We have a conclusion slide. I mean, at some point we have a conclusion slide. But this is essentially what we do. So let me, I guess, take your questions about either this or general questions. Олег.
Thank you for your paper. Your model are very similar to the Scott proposed, which have assessed has the central bank commitment and non-commitment and influence to the getting real exchange rate equilibrium rate. And it's very similar to your new Keynesian model built, but you are innovated by measuring the financial shocks, spillovers, production traps, spillovers have influence in the real exchange rate quoting. But my question concerns to the Ukrainian reality. How we can assess the equilibrium real exchange rate for hryvnias as the shocks of financial shocks or production trap shocks are not have a very big influence on innovation of the real exchange rate trend for hryvnia. Thank you.
Okay. Well, I don't know the paper that you mentioned, so if you have a reference, please send it to me. I don't know that paper. So this is a good question. So how do you think about countries like Ukraine, or I guess Russia for that matter, or a bunch of other commodity exporting countries? So the commodity exporting countries is about this shock, right? So the commodity price movements, it's like a change in the demand for the goods that the country produces, basically. So and you see that these shocks are also have to be quite important for all countries. But if you're thinking about, Ukrainian economy, I think it would be sort of, it's actually, you can take the model and do the decomposition of shocks using the model, right? You can take the data and filter the data through the model and see which shocks the model says are important. And then, my conjecture would be that these shocks are more important, right? The commodity price movements will be more important for exchange rate movements. So this is the first part of the question, which shocks drive it. So that would be my guess. The second part is how to evaluate equilibrium real exchange rates. Well, this is a hard question. I mean, I think this whole notion of deviating from equilibrium exchange rate is a bit crazy because everything that you observe in the data is an outcome of some equilibrium. So whatever you observe is an equilibrium exchange rate. So you could ask a question differently. You can ask, what is the counterfactual equilibrium value of exchange rate if the government did a different policy, right? So you observe one equilibrium exchange rate, but if government did something else, what could be the alternative equilibrium exchange rate, right? But then you have to specify what you think the government is doing now and what would be the alternative policy, and then you can sort of discuss it. So you see, that's why, my answer would be whatever you observe in the data is the equilibrium exchange rate, given, the policies. This question typically arises in the context, should the government do something, some type of policy to devalue the exchange rate? So that's the paper I actually presented. This was one of the parts of the paper I presented yesterday at the conference. And so the answer is typically you can do much better things that move in the exchange rate. So it's a long conversation. So I'm probably going to just give you a brief answer. So, exchange rate policies tend to be third best. They're definitely not first best and highly likely not second best, in the following sense that they exist. For every inefficiency in the economy that you can identify, they tend to exist more direct policy instruments. Moving the exchange rate is a very indirect way of getting at the problem. And then typically what people say, so Denny Rodrik is a sort of famous economists who promoted the exchange rate devaluation policies as like a growth policies. So the idea is that somehow you don't have access to direct policy tools. That direct policy tools are too complicated, or the government doesn't have enough information or doesn't have enough resources to use the direct policy tools. By direct policy tools, I mean like subsidies to particular sectors, or like labor subsidies, or other types of things. And so if you don't have those, maybe you go for a devalued exchange rate. Yeah.
Thank you so much for your presentation. Actually, I would like to ask the more personal question.
Okay.
So you have pretty outstanding career path. Having graduated from Russia, you entered Harvard and then teach at Princeton. Could you mention the main challenges you faced while studying at PhD program and further? So, like, what to keep in mind if you want to pursue similar path? Thank you.
Yeah. So, I mean, academic career academic career requires particular skills. They're not necessarily correlated with the mathematical skills that you get early on in your education. So I went through New Economic School, which I imagine is similar to Kyiv School of Economics, right? But so New Economic School really is targeted for like testing people on their formal mathematical skills. That's one ingredient that's quite important, but it's sort of not the most important skill to have in a PhD program. So typically in most PhD programs, you have, even the top PhD programs like Harvard or Princeton, we send maybe only half of our students on the academic market, and the other half goes to a private sector. So they get amazingly well-paid jobs, much more than what I get paid for my work. But it just kind of half of our students, and these are the top programs, right? And even in our top programs, half of the students sort of don't go on the academic market. And so here's an example. It's like, I mean, first of all, when Russian students tend to come to US, I'm not sure about sort of Ukrainian students as much, but Russian students come very technically prepared. So the first year classes seem to be very easy. It's very hard to start reading actively, right? So the first 2 years of the PhD program, you really have to start reading, right? So you have to, I don't know, like read, in your field, you have to read 200 papers, right? Something like that over the first 2 years. That's hard work. If you can do problem sets easily, you sort of tend not to read papers because you don't have incentives to, and like the American students, they tend to read papers to do the problem sets, right? And this is a very important skill actually to be able to read papers. So this is where, a lot of the Russian-speaking students sort of start lagging behind is, they solve problems well, but then they, don't catch up with the literature. And that's kind of like a big skill to develop, to be able to read literature fast. So that's sort of like a complicated skill that not everybody has. So you have to like what other people write. So some people only like what they write and don't like what others people write. So I have a friend who is a linguist, and he says, in the afternoon I read papers of others, and in the morning I read papers of my own, right? So the other thing is some people like to read papers of others, but don't like to write papers of their own, right? So that's another thing that can go wrong, right? I mean, you don't know this ex ante, right? So you don't know before you apply to PhD, you're not going to have information about that. That's sort of like some hidden information about yourself that you will only learn by the 3rd year of the PhD program, right? And it's totally fine, right? I mean, like I was sitting next to a person who was in the office who was complaining every day how much he hates, being an academic. And so the other thing is you write papers. So writing each paper is like your baby, right? So and so then some people start criticizing your papers, right? And so they say, your baby has crooked legs, and sort of it cannot speak straight, and what did you do wrong? And this is kind of painful experience, right? And so I mean, people say it to your face. In economic profession, it's a very sort of blunt profession where people say directly what they think about your work, but also then you send your work to journals and you get referee reports, and those are completely nasty, and then you're depressed for the next week after you read this report, right? So even the most successful people, right, typically you send a paper to the top journal, you get like 2-3 rejections, even if it's a very good paper, before you get it published. So a lot of people just don't like that. So my classmate, he really hated that part of the profession. And so those are all, even if you like enjoy writing good papers, sometimes you hate publishing them, right? And then, So the way I think about it, it's a very specific mix of skills that you need. But it's actually a very fun profession. So you go to a PhD, you apply to the best PhD, you try to get to the best PhD program you can get to. You study there for a couple of years. If things don't work out, you go to Wall Street or, become an investment banker. If things work out, you get actually access to a great profession that's enjoyable. But you have to enjoy it too, and not everybody really does it. So, I mean, you have to keep statistical probabilities in mind, right? So it's at each stage of the process, a lot of people go to other professions, right? And so, people become assistant professors, and half of them, leave academia before they become, senior professors and so on. So that's also typical.
Any other questions of academic or personal method? I had a question about, I think it's very supplementary. You have already published several pretty impressive papers, and you're continuing doing this, as we see. How you come up with those ideas? Is there any way how to generate a good idea? Not necessarily publishable, but just a good idea that you're fascinated with. Just how you live with this research and how you generate the new research.
Yeah, so you know Ricardo Caballera, right? So Ricardo Caballera at MIT, he was interviewing me on the job market, and he tortured me with his questions, like, how do you come up with ideas? Like, explain to me the process. I mean, it's coming up with ideas is very endogenous, right? You do work, you start with bad ideas, and gradually the ideas get better. There is a lot of learning by doing, right? So the point is, at first, you need to get to the frontier of the literature. You have to have some guidance which papers to read. You don't want to read randomly, right? You need some guidance from the professors to tell you which sequence of papers you need to read to figure out where the frontier of the literature is, right? That typically takes 2-3 years of PhD, right? To figure out what's the frontier of knowledge, even in a narrow area. And the next 2-3 years of PhD is trying to do something which pushes that frontier a little forward, right? And so academic work is very different from policy work and from private sector business work in the following senses. In academic work, the first thing that matters is internal coherence of what you say, right? It doesn't matter, anything else would not matter if what you're saying is not internally coherent, right? If you write a model which doesn't hold together, or if you do empirics which violates identification assumptions, right? Or stuff like that. So the first thing you have to do is to figure out how to do internally coherent research. Then it has to be novel. Nobody going to care about internal coherent research. I mean, if it's not internal coherent, that's it. Even if it's internally coherent, right, then people want it to be novel. It has to be completely new that, nobody ever has done anything like this, right? So this is the second requirement. And if these two requirements are satisfied, people want it to be important, right? So most of academic work is not very important, right? It ends up being internally coherent, novel, but not particularly important, right? So if you think about policymakers or business people, they don't care about novelty so much, and they don't care about internal coherence. They care about importance, right? And being able to push through the ideas and so on, right? So academic research is very different. So basically the idea is that the first couple of years of PhD, you have to get to that frontier and kind of try to understand what it means to sort of contribute there on the margin. And typically the contributions are very marginal contributions. And so the more you work, the more you learn what are the important questions, right? And so the big benefit of being in the US actually, which is the sort of this most developed economic sort of academic market, right, is that you get exposed to the new ideas very fast. So you see what's being exciting right now, and you start working on topics that are exciting. So, as an example, right, so people sometimes have brilliant ideas. That doesn't happen very often, right? But then when one brilliant idea shows up, it typically triggers, thousands of papers written, pushing this idea forward, right? And so if you're close to the place where the ideas are developed, right, it's very easy to sort of jump the wagon and start sort of contributing. So a good example is, international trade literature kind of developed in this, spins, right? So, in the 70s, people looked at the data and they realized that countries it's mostly rich countries that trade between themselves, and rich countries mostly trade within the same sectors, right? So US sells airplanes to Japan, and Japan sells ships to US, right? And so it seems like similar industries, but for some reason, similar countries trade in similar industries, right? And the whole trade literature before was saying that it should be different countries trade in different goods, right? And it's just not true in the data. And so people started thinking about this idea of intra-industry trade, right? And then Paul Krugman wrote the 79 and 80 papers on this, which sort of captured this idea of intra-industry trade. Everybody was discussing it, but nobody knew how to model it, right? And so then there was this Dixit-Stiglitz paper, how to model, love for variety, demand for variety, the 77 paper. And then Krugman wrote the 79 and the 80 paper, and he got the Nobel Prize for it, right? But then after Krugman, there was 2 decades of research pushing this basic idea of Krugman forward, right? So the whole industry of trade economists was busy, doing that. And 20 years later, people started looking even at more granular data. They were looking at the micro data on how trade is done, and what they saw is the trade is done by very few firms, basically, right? So very few firms in each country export. Even in the industries where the countries export a lot, it's just the few firms that do it, and people needed a model at the firm level, and so this was the Melitz model, which was his PhD dissertation in the early 2000s, right? And so now this paper has 10,000 sites, so it means that 10,000 different papers were published, like kind of pushing this idea of the Melitz model ahead. And so this is how most of the research is done. You try to catch the idea that's hot right now. So in macro, after the financial crisis, everybody started putting financial frictions into macro models. So you see thousands of dissertations written on this topic. So this is how most of the idea is done, right? So the novelty is very incremental typically, and the importance is typically incremental, but that's how research is done, and you build it step by step. So right now in the US, the biggest topic is inequality probably. So a lot of people are thinking about why inequality has increased so much in the last 30 years. What are the policies to deal with it and stuff like that, right? And so, this is how research is done, and people talk to each other. You go to conferences, you see what people are excited about. And then there is Kiminori Matsuyama, I don't know if you know him, it's a guy from Northwestern, and he always says, I'm too stupid to work on things that other people work on, so I find things that, nobody works on. And so that's, and he's a remarkably successful economist, obviously.
Thank you. Anybody else before we give? Okay.
My question is very simple. Who is your Stephen Hawking in a macroeconomics world?
I don't know. There are, okay, so let me answer a different question, which might give you a sense. So the thing that impressed me the most, right, when I came to do PhD at Harvard, so was that you come on Harvard campus and you suddenly see Robert Barrow and Greg Menke walking around, right? And these are real people. So these are the people that you thought were only these were some people whose names you saw in the textbooks. Suddenly these people walk, you walk among these people, right? So that's the amazing thing, right? It's economics profession is not a very large profession. Everybody knows each other, right? There are a few giants in the profession, but the point is that you get direct access to them, right? And so it's in this sense you are able to touch the greatness, right, sort of in front of you. And these are very smart people. But also the other thing is, so I worked as a research assistant with Daron Acemoglu, and I'm a co-author of Elkan and Helpman. So if you think these are like the 2 really big names in economics, right? And so you think that these people are like superhuman, right? Like the amount of papers that they write and the quality of papers, and then when you work with them, you realize that they're just exactly humans like everybody else, that they just do a lot of little steps very fast. They do exactly the steps I would do when I solve the model or write a paper, but they're able to concentrate and do many, many steps, very, very fast, right? And that's what sort of sets apart, if you think about Daron Acemoglu, he's like the most prolific writer in the last 10 years, but he's really doing the same thing as, I'd be doing, but just doing it very well and very fast, right? And so this is sort of, and I think it's true in every profession that you take, right? So that's what sets people apart.
I had another question. Some of our students ask us, once they try to choose a field, they start usually with macro or micro, and than empirics or theory. Does it actually matter?
Well, macro, of course, right?
Well, we are historically micro department. We have only like 1.5 macroeconomists, so we advise mostly on micro. But still, does it actually matter to be? Is there any like external path to be more successful, macro, empirics, or theory? Because it seems that theory is a bit easier to publish because you don't have to mingle with data.
I would disagree with that. So it's a big question with a lot of things in it, but a couple of things. So I think it's much easier to be an empirical economist. So theory is a field of very thick tails, in the sense that in order to be a successful theorist, you have to be very far out on the tail of the distribution. Nobody wants second best theory, right? Like, people only want the first best theory, and this is the place with the huge increase in returns, right? So you really, if you want to be a theorist, you have to be way out there in the distribution, right? This is the only way to be a successful theorist. It's true that theory maybe seem to be a little easy to produce because you just come up with models, write them down, but it's very hard to publish, actually. Empirics, second best empirics is often as good as first best empirics because the elasticity of substitution between empirical work is not very high, right? So you find a specific question, you address it in the best way you can, and typically, like as long as you found an interesting question and you did like your identification right and stuff like that, right? You can write good empirical work. So I think the big mistake that actually Russian students do as well is they come to PhD and they try to be theorists because they had more technical training. I think it's very important to gain skills of working with data actually early on in the PhD program because much more likely you will end up writing an empirical thesis actually when you go. It's just much easier to write a good thesis which is empirical or at least partly empirical. So this is one thing. So the other thing is there is a lot of past dependence. You tend to do what you have learned, right? So if you had a very good professor in econometrics, you might do econometrics, right? So the benefit of going to the best PhD programs is you have more choice, right? So you have good professors across the board. When you go to lower ranked PhD programs, you might get access only to one very good professor, right? In whatever field he was interested in, right? And it becomes past dependent. So ideally you should choose what you're good at and what you like more, right? It's some combination of the two. But oftentimes you choose what, you need some person to teach you how to do things, right? There is a lot of learning by doing, and you end up, you should try to learn from the kind of the best people, and oftentimes you're constrained in the choice of the field, right? But okay, and so the last part of the question was, so if you look at the recent John Bates Clark's medal, so John Bates Clark is the medal for an economist working in the US under age of 40. So if you look at them, they were disproportionately empirical. Almost like there was, actually last year, Yuliy Sannikov got the Clark medal. He's a theorist, but most of maybe the last 6 out of 7 Clark medals were all empirical, heavily empirical. So it looks like it looks like economics became a rich enough field that we have enough theories, and the binding constraint is good empirical work. Or in fields like macro, it's very hard to do empirical work, so people start doing quantitative work, right? In macro, the alternative to empirical work is, quantitative work. You write down big models which don't have clear predictions, and you discipline them with data in some ways, right? Okay.
It seems there are no many more questions. That probably seems that we have to wrap up. And this is the final event of our week of economics here at Kyiv School of Economics, but this is certainly not the end. So please follow our advertisement. We are going to have another one probably in the fall. We would like to thank National Bank of Ukraine and Visa Ukraine, which is both public and corporate sector, for supporting us. We would like to thank Olegom Іцхокі for being such a brilliant crown, the cherry on the top of this cake of this week. Thank you very much, and welcome to us again in the future.